Hey guys, welcome to my second chemistry video. As you can see, I am on slide 75 of class kick, and I will go ahead and leave everything here when I'm done talking so that you can look back on it and finish your homework. Today we are picking up where we left off yesterday or whenever you watched the last video, and we are again talking about stoichiometry. And remember, stoichiometry is about the elements and how much. So stoichiometry helps us look at a balanced chemical equation like maybe this one and figure out how much KCl or how much O2 we can make with a given quantity of KClO3 or vice versa. It doesn't matter which one you pick because we have these wonderful balanced coefficients here that tell us the ratio. And speaking of ratios, we learned the one new thing last video. We learned the one new thing, and that was something called mole ratios. And remember, a mole ratio looks at the balanced chemical equation and takes these coefficients into consideration, and we can say like 3 moles of O2 for every, I don't know, pick one, 2 moles of KCl, and we can use that to cancel units out and to go from one substance to another given a balanced chemical equation. So let me get rid of all this stuff. Now today, hopefully you've already noticed that we are looking at mass-to-mass problems. So yesterday, or on the previous video, to get used to saying that, we were looking at mole-to-mole problems. In other words, our given was in moles, and we were converting to moles, but now we're going from mass to mass. But it's okay because I already taught you how to use this awesome thing that I have over here called a mole map. So today, we're going to be going from here to moles to be able to use our mole ratio and then converting back. So the good thing about these problems is they do have a pattern, and I'll go ahead and write the pattern up here for mass-to-mass problems. If you're going to do a mass-to-mass problem, you are going to go, I'm going to zoom in so it's easier to write, you're going to go from grams to moles, and then you can use your mole ratio, and then you simply convert back to grams. It's called a mass-to-mass problem because you start in grams and you end in grams. Something that I want to add really quick, let me make those arrows go away so it's easier to see. When you are making your gram to mole conversion, that's when you're going to use your mole map. So we'll write that down here so we know what we have to use. Then when you're doing your mole ratio, that's when you use the balanced chemical equation. And then when you're converting back to grams, you're going to use that mole map again. And now when I zoom out, it'll be easier to do. Okay, so we have that, and we should probably review our steps for these problems. I think I'll write our steps right down here in this open spot so you guys have them on this slide again. Remember, our steps for doing all of these problems are as follows. Number 1, We have to read the problem. Number 2, we have to single underline the given. Number 3, we have to double underline what we are trying to find. Number 4, we have to convert from our single underline to our double underline. Number 5, we have to do fun stuff called math magic to get our answer. Magic. Decorate magic because we have some extra time. We have nothing but time. That's what my husband says. Number 6. Number 6. Then we have to do units and significant figures. Okay, so let's look over here at this problem. So step number one, we have to read the problem. It says, how many grams of potassium chloride are produced if 25 grams of potassium chlorate decompose? So let's go back to light purple. And our second step says, underline the given. So if we're looking through this problem right here, we're scanning for a number. Oh, found a number. So I'm going to underline. So our given is 25 grams of potassium chlorate. Now we have to double underline what we are trying to find. So what are we trying to find? What is it asking us? How many grams of potassium chloride? So now we double underline that. Okay, good to go. Now, something that I do that just makes it a little bit easier. If you look, like in our problem, we have words, but in our chemical equation, we have all these symbols. So I don't necessarily like that, but that's just the way it is, and I don't like to get confused because that's hard. So what I do is I say, okay, potassium chlorate and potassium chloride. And then I look for them in this balanced chemical equation, and I go up here and I single and double underline those two. So I know when I'm doing my mole ratio for my balanced chemical equation that I'm looking at the right stuff. So 25 grams of potassium chlorate. Oh, potassium chlorate. Okay, so this is potassium chlorate. And then we're converting to grams of potassium chloride. Potassium chloride is here, so I double underline that. All right, ready to move on. So we are going to start, and if you're following along with the steps, we're on step number 4. So we can convert from our single underline to our double underline. So our single underline thing was 25 grams of KClO3. So I'm going to set that up in a field goal. Now I'm going to look up here at my pattern. So it says go from grams to moles first. Grams to moles. Now, thankfully, back in chapter 10, I taught you guys how to use the mole map. And that means we have to go from grams, which is mass, grams, to moles. In order to go from, let me get this purple stuff out of here. In order to go from grams to moles, I have to go down this road to Mole City. And right here is my toll that I have to pay to go there. So it says 1 mole over the molar mass. So that's fine. 1 mole of KClO3 over the molar mass. Now remember, in order to get the molar mass, I have to use the periodic table. So, lucky for you, I have included a periodic table if you don't have the one from school. So if we look at this, we have KClO3. So potassium, here we go. Let me clear this out. Okay, so potassium is 39.1 plus, what else do we have? Cl. So 35.4 plus, O is 16, but look, we have 3 of them. Okay, so plus parentheses 16 times 3, so we don't mess up order of operations. So that equals 122.5. So we got that. Now we can go back up here to our problem, maybe. And we can go 122.5 grams of KClO3. All right. Now, what units cancel out? Let's check. Our units that cancel out, let me see if I'm on the, yeah, okay, there's the smallest one. Our units that cancel out are grams of KClO3, so that cancels out. And now we are in moles of KClO3. So let's look at our pattern up here. We're in moles, so now we can use our mole ratio. So remember, mole ratios come from the balanced chemical equation. And watch this magic right here. I look up here at my single underlined, and that's a 2. So I have 2 moles of, better zoom in or else I'm not going to fit it, KClO3 for every 2 moles, okay, 2 moles of KCl. Now, what units cancel out? Remember, units cancel out diagonally. So if we look, our moles of KClO3 cancel out. And if I stopped right now, I would be in moles of KCl. But the problem is asking us for grams of KCl. So now, if I look back up here, I have one more step to do, and that's to go from my mole ratio to the grams. Now it says that I have to use my mole map again, so I better check that out. Now, I'm in Mole City, but now I want to go back to grams. So I have to pay this toll in order to drive down that road. It's molar mass over 1 mole. So I'm going to go up here. I'm going to say, okay, molar mass over 1 mole. So 1 mole of KCl. Ooh, I need molar mass again. Okay, I have to go back down here and look. So KCl this time. So K is 39.1 right there. And Cl is 35.4. Okay. So clear. So, oh, I forget. 39.1 plus 35.4 equals 74.5. So 74.5. So if I go here, 74.5 grams of KCl. What units cancel out? Moles of KCl. What unit am I in? What? I'm in grams of KCl. What was it asking me for? Grams of KCl. I win. So, now I just have to do some math magic. Remember, you multiply everything on the top and divide by everything on the bottom. So, math is going to be a little bit hard, but that's okay. So, 25 times 2 times 74.5. So, 74.5 times 2 times, what was it? I forget. Times 25. Oh, is there a back button? Oh, yeah, okay, good. Times 25 equals 3,025. So, 3,725. Okay, on the bottom, 122.5 times 2. So, 122.5. Oh, no. 122.5 times 2. Could have done that one in my head. Okay, 245. 245 goes here. Now we have to divide. So 3725, 245. So 3745 divided by 245 equals 15.2857. So we got 15.2857. But that cannot be our final answer because we need to figure out significant figures. So if we look, the number we started with always gives us our significant figures. 25 has 2 significant figures. So my answer can only have 2 significant figures. The 2 tells the 5 to stay where it is. So my answer is 15 grams of KCl. All right. All done. Well, let's look at one more. Let's look at number 2 and try number 2 together as well. Step number 1 says read the problem. How many grams of hydrogen are necessary to react completely with 50 grams of nitrogen in the above reaction? So we have to find our given, which is right here. We have to double underline what we're trying to find. So we're trying to find grams of hydrogen. And just like in my last reaction, I'm going to look at my balanced equation to figure out what I'm working with. Okay, so I'm going to be working with this guy right here and 50 grams of nitrogen. Okay, so here's my single underline right there. Step number 4 says it's time to convert. Time to convert between the thing we underlined one time to the thing that we underlined twice. So the given in the problem is 50 grams of nitrogen. So we have 50 grams of N2. Now our steps according to this up here says go from grams to moles. going to look at that mole map again. And we're going to go from grams to moles. If we look, going from grams to moles is 1 mole over the molar mass. So 1 mole of N2. And again, up here it says we have to use the periodic table. Molar mass is from the periodic table. So we have 2 nitrogens, which should make our mass pretty easy to figure out. If we look, nitrogen is right here, and it's 14. So 14 plus 14 is 28. So I have 28 grams of N2. Units that cancel out. I'm going to use light pink this time. These cancel. Now I'm in moles of N2. So now that I'm in moles of N2, I can use my mole ratio. You have to be in moles to use a mole ratio. That's the rule. So remember, our mole ratio comes from our balanced chemical equation. I want moles of N2 to cancel out. So my moles of N2 have to go down here. And my moles of the thing I double underlined has to go at the top. So what I'm trying to find. So moles of H2. And now remember, what was that? Get off there. Okay, so now remember, we have to look at our balanced chemical equation. Moles of N2, that's 1, because there's a 1 in front of that N2. Remember, it's 1, understood 1. And then moles of H2, what number's in front of that? A 3. What units cancel out? Moles of N2. Cancel, cancel. Now, we're in moles of H2. What's the next step? Remember, it's asking us for grams right there. So now we have to convert back to grams, but that'll be pretty easy. So, look at our mole map. Now we have to use molar mass over 1 mole. Okay, we can do that. We're good. Okay, we have 1 mole of H2 on the bottom. Now, molar mass of hydrogen. If we look all the way down here, hydrogen has a mass of 1.1, but we have 2 of them. Get this scrolling under control. So 2.0 grams of H2. And units that cancel out, moles of H2 cancel diagonally. Now I'm in grams of H2. Now I have to do some math magic. I'm going to multiply everything on the top divided by everything on the bottom. So I'm going to say equals, and the bottom's really easy because it's 28 times 1 times 1. So that is a big old 28. And now on top, we have 50 times 2 times 3. So 50 times 2 times 3. It's 300. I should have known that. Okay, that's 300. So 300 divided by 28. We can do that. 300 divided by 28 equals 10.714. All right, so I'm going to write 10.7142. 0.7142. I'm going to write that right here, but how many significant figures can I have? I'm going to look at my given number because that tells me significant figures, and I have 50.0. Now, that is 3 significant figures. So I can keep the 1, I can keep the 0 in the middle because it's a sandwich. and I have to look at the 7 over here, and I have to look at the 1 next to it. So the 1 says, hey 7, you just stay a 7. 7s are good. So we don't round, we go 10.7 apples, donuts, what? Nope. Grams of H2. And that's how we do that problem. Now, I would like for you guys to please do 3, 4, and 5 on your own. And then I would like to, just before I sign off, I would like you guys to try these as well. This one, these over here, same stoichiometry, but now we're looking at volume to volume. So the pattern for this, really easy, is from liters to moles. Then you can use your mole ratio. And then go back to liters. So, instead of using, instead of using mass city, now we're using volume city. So now you're using this part right here. You're using these conversion factors, but our mole ratio still comes from our balanced chemical equation. So if we look at this problem really fast before I sign off, it says what volume of hydrogen is necessary to react with, there's a number, 5 liters of nitrogen. So you're going to go from liters to moles using your mole map. And then use your mole ratio from your balanced chemical equation, BCE. And then go back to liters using the mole map. So the only thing we're changing in these problems over here is this and this. We're just going down a different road, paying a different toll. That's it. So I would also like you to try number 1, 2, and 3. So work on those. Let me know if you have any questions. And as always, thanks for being part of my video.